Traditional teaching of measurement tends to focus on calculating quantities such as area and volume using formula and converting between units. There are many rules associated with these calculations, often given to students over a short time frame and usually without the support of any hands-on or three-dimensional experience to internalise the concept or to make the formula meaningful. So it's not surprising that students tend to get confused about which formula to use and when to use it. I believe that participating in hands-on learning experiences creates a firm basis for understanding the concept and also the meaning behind the formula. Hands-on activities not only clarify measurement concepts such as area and volume at the time, but also create lasting visual memories to fall back on. Okay, so we're going to be making an origami box like this, which is probably the simplest origami box you can make. We have instructions, and then when we get to the difficult bit, I can show you. So first of all, somebody can go around and let everybody choose the colour that they will feel happy with. Now, what I would like you to notice that on the way, even though it's very ordinary, we can do a lot of language with this. What fraction have I got? Half. Brilliant. And then I fold it again. The next step. What fraction have I got now? Well, actually, look, no, I've still got a half. And now I've got a quarter. And how would I know that? If I open it out, I can see that there are 4 equal pieces. Just keep following the instructions. There will be a moment when you get a little bit stuck. So.
Just one?
Well, let me tell you.
Don't panic when you get stuck.
Don't panic. Not. So we're into the middle.
Into the middle.
Open up. How are we going?
Okay, good so far. Open up again.
To the first line.
I think I'm up to the point almost where I'm going to get stuck.
Not yet. Okay.
You're not allowed to be stuck yet. Oh, okay.
Here we go with the folds.
Okay, fold in the sides where you've just folded the points. Fold on the fold one. So that's that. Oh no. Okay, I'm not stuck. Not stuck.
No.
Just choose any to be the right and the left side.
You have to go in a different group if you're going to be stuck with early.
Turn it over. Okay.
Fold into the middle.
Right and left sides up so they meet.
First of all, fold into the middle.
Okay. Into the centre.
This is the bit, okay? Has everybody got two? Okay, there is the bit. No, this is the bit where it gets a bit tricky. And try as we might to change the instructions, it got no less tricky. So
A word missing. To open the centre. Oh, I see.
tuck the flaps too.
Oh, so don't take them out.
It doesn't matter. All you're doing here is getting the flaps out of the way so that you can fold the corners in.
Oh.
That's all you're doing.
You're right, that is.
Fold the corners in.
Yes, but we tried it many other ways.
Yeah.
To
explain it. Oh, I see. So all the corners folded in.
Other than maybe if the word instruction explained the rationale for lifting them. I thought I was going to lift and sort of magically
that's what I thought.
something
do
was going to
something,
happen.
whereas as soon as you said you're just getting them out of
Just
the way.
getting them out of the way.
Yeah.
Maybe you could even write that. And then it looks like that.
But that's what it looks like on the little diagram. You've got all the dark and just a slight bit of the...
Maybe if we keep going. Oh, look, just keep going, just keep going.
Just her face is there.
Yeah, just keep opening, keep opening. Wow! Oh, look at that.
They missed the instruction.
Wow!
You can actually see it. It shows you a diagram. It shows you a diagram.
That's nice.
We're not that sort of learners.
But there is a point in every origami that if you don't have a person, you need one to help you. Okay, now there was a purpose for this. It wasn't just to do the origami. Really what I want to say about this is in the numeracy curriculum, there's always a little bit about space and shape and about understanding two-dimensional and three-dimensional diagrams. And I have to tell you, adults from some cultures are excellent at doing this stuff, and some cultures they've never seen three-dimensional things represented in diagrammatic form. So doing this sort of exercise is at least acclimatising them to the idea that people do represent things this way, and you can help them along. I worked with a group of migrant women who had been working in factories ever since they came here after the war, and they'd been retrenched and they were all going back to school, and we had some problem-solving stations around the room, a lot of things that involved creating things with blocks, not as you were doing from clues yesterday, but just from a diagram on the wall, and they really looked at this thing and looked at the blocks and could make no head or tail of it. So I realised how cultural or to do with our education system that we're used to these things. Of course, if you go to IKEA and you buy your furniture, or any of those places that sell flat packs, you've got to understand diagrams. All right, now we get a bit competitive. Get the sturdiest box at your table. So which is the one that looks the best? We're going to do a guess, estimate and measure. Now your task is to first guess, then estimate how many of these jelly beans will fit in that box. Later, our measure will be to actually do a count. Okay. So guess, then use your jelly beans to estimate, then later we'll do the accurate. You can all do your own guess, but the estimate I'd like you to work out together. Okay. You can all make your own guess, and then all.
Let's have this.
Okay. Now we want a joint estimate.
How many did you get? So this is side.
If you just dump them,
We go like this.
And then we go
8 across.
yeah. Assuming you stack
Some are
them
fatter
neatly.
and shorter.
See, that's why it's an estimate. Right.
Okay,
There's
so
only 5 that way.
5, 8.
25 times 4.
40. Yes, we decided.
Okay, so we've got
Okay. So we've said 4 64.
stacked.
Yeah.
Okay, yes.
One on
Yes.
Has everybody got an estimate ready? Describe how they got their estimate. So you line them up sort of like that, right?
We had some trouble working out short sides and long sides of jelly.
Yes, because it's a bit risky to decide, oh, if it's 1, 2, 3, 4, 5, 6, 7 there, then it'll be 7 there, but it's not because we've got long ones, and so we need to know that they're rows and columns, or they go like that. People will do it differently. They will fill up a quarter. So that one gives you a different way of thinking anyway. So, all right, so once you've decided that you've got, how many did go along that way? 7. Oh. Okay, I'm going with 7 just for the moment because I think that's what I drew. Yeah.
The evidence is gone.
And how many went down here? 5.
We were 8 before.
All right, so what does that tell you?
35.
It's 35 on one flat surface.
And how do we know if you had to explain to somebody that didn't automatically know they were going to multiply, how would you know that that was 35?
7 lines of 5.
Yes, okay, so it's 7 lines or 5 lines and each of them's got 7, or it's 7 lines that way and each of them's got 5 in it, so it's 7 lots of 5, and so it's 7 times 5 is 35 on the bottom or on the base. If we're speaking in mathematical terms, on the base we've got 7 times 5's 35 jelly beans on the base. So what did you do next? Because that's not filling the box, is it?
Stack them.
You stacked them?
Up the side.
Okay, so...
Yeah.
And how many?
We thought 4.
Yeah, we all agreed 4.
So we got 4. I'll get rid of that little bit of spare box there. So how can we explain that?
You need 4 layers of 35 to fill it.
Yeah, so again, it's 4 lots of 35, which was the base. So it's 4 lots of the base. And what does that give us?
35 plus 35.
How did that go with your guesses?
Way out.
Okay, now it needs to be straight at the sides. Yes, now somebody hold it in shape and somebody scoop the excess off the top.
Take out the black ones, they're horrible.
Yeah. Okay, so now you have the task of counting, please. Okay, we await anxiously the count over here. Now, some of the extension exercises you can do with students at a higher level. First one is, if I halve the sides of the paper, how many jelly beans would I fit in the box that results? If I halve the length of the paper, how many jelly beans might result?
You mean?
Well, it still has to be a square or you can't make a box. So if I halve
The size of the paper.
all the sides, and I'm going to give you this on a piece of paper. So that's one of the extensions. And of course, this is a slightly trick question. So when you discover that it's not just half the number of jelly beans, the real challenge task then is, can you make a box that will hold exactly half the jelly beans? But that's a real extension exercise for your higher level. Okay, so what's the result? How many?
158 jelly beans.
158. So, what was your estimate over here?
160?
No, 160.
No.
Oh, okay.
And your estimate was?
160.
160?
160.
Theirs was 160. 150. 160.
160? 140?
You just want more jelly beans in your box.
This is pretty good. Now, what would account for a slight difference in the estimates and the guess? Oh, not the guess, the actual accurate count.
Ones we ate?
Yes, because when we're throwing them in and not stacking them, we're fitting a few more in because they're filling in some of those spaces. So we would expect it to be a rough, but it's not bad. It's not bad for the sort of estimate that you're doing. Okay, so that's really good. What are we doing here? Why are we doing this exercise? I know it's fun, and I know that we're doing a lot of fun things, but most of them have a purpose to do with making meaning.
Sometimes volume is very difficult for students to see and to conceptualise and to pull apart, and I've often struggled for something that was concrete to be able to show them what it looks like.
Yeah, well, volume, it is three-dimensional, and we give it as a two-dimensional rule on a blackboard or a piece of paper. It doesn't make sense. Also,
Students got a chance to share all their multiplication ideas, how they do.
Yeah, lots of things get shared that you as the teacher can't control in any way, but really what you're wanting to do is to make sure that when they get a rule or a formula, it has some meaning to them. This way, they're going to tell you the rule or the formula. And those who thought to do it this way are going to get an idea of this area of the base. We've discovered that a quarter of them will fit this many, so the whole base will fit this. So on the way, we're trying to develop language. The area of the base is this many beans. And these layers are what gets translated as the height. Okay, so we give people a formula that goes length by width by height. In fact, the more durable formula is it's the area of the base by the height.
That means if you've got to be regular basis.
And the height is always the number of layers. So it's how many of these things we're stacking on top of each other. Now, obviously, for more regular volume, we're not talking about jelly beans, we're talking about cubes. And so it's how many cubes will fit on the bottom. That gives us the area of the base. How many will stack up the side? That gives us the height. But I think with the jelly beans not being a regular shape, they actually have to think about that business of, and it makes it a more, not just a formula, but a more thought out thing, that there's this many rows and we can stack that many rows onto the bottom to fill it. And I think people have to think more about it. And what shapes will this formula work for, this rule, area of the base by height? What else can you use it for besides a box shape?
Cylinder.
Yeah, can I use it for this?
Mm-hmm. Yeah.
Yep. If I can find the area of that base by the height, I can find it for lots of different things. A triangular prism, we call it. But anyway, anything that's got straight sides and is a matter of the base and all the way up, it's the same, then you can use this formula, which is not length by width by height, but something that you visualise, area of the base times the height. And it's really good to get students to put a formula into their own language for their own context, because I was speaking to a CAVS teacher once who was trying to teach volume formula to the plumbers. Now, the most common things they have to do about volume is about digging trenches. And it's not area of base by height for them, it's actually the cross-section of the trench by the length. But what they need to be able to envisage is what they're doing. They're cutting up one section and they're working out how many of these are going to fit. And they need to translate the formula into their own language, not length by width by height, but, okay, it's the cross-section by the length if it's a trench. So it's about making something that makes sense for them. This group of teachers took part in a series of activities which I put together because each of them contributes in a different way to gaining a sense of volume as a three-dimensional measurement concept. Making the origami box was an example of a paper folding exercise linking two-dimensional diagrams with three-dimensional figures. It can be valuable in its own right, a very satisfying experience and a lot of fun. Although we did it quite quickly, for some students it might take a lot longer and become the beginning of an interest in paper folding. Guessing and later counting the jelly beans emphasised the volume concept, how much of something or how many things will fit in a space. Estimating the number of jelly beans invited participants to think of their own strategies and led them into the meaning of rules for calculating volume while visiting the concept of area on the way. 2 extension activities were suggested as a follow-up. These reinforce the ideas and provide a lot of incidental practice at making the boxes. They're a valuable way to explore the effects on area and volume when lengths are scaled up or down, as in halving or doubling. The results are surprising. Try it yourself. The jelly bean exercise was what I call a guess, estimate and measure activity. Several other simpler guess, estimate and measure activities are available on the Velbeck website. These length, weight and volume activities are designed to help adult learners develop a sense of measurement.
Authorised by the Government of Western Australia, Perth.